Alright, so now what we're going to do is we're going to show you how to use a spectral scan function. If we open up the Manage Protocols and click on an FI and New, then at the very bottom you'll see the spectral scan selection. Click OK here, and the first thing we're going to do is give it a name. So go ahead and type in a name up here, whatever that name might be for your excitation FI spectral scan, and choose your microplate definition just like always for the protocol. After that's done, we're going to go in and we're going to make sure that we have all of the ranges for the excitation and emission done right. So by clicking on the rainbow square here, it brings up a new window with this range. The green is our range that we're going to scan for the excitation in. And you can either move these boxes or you can enter the values. So if we move the emission value at 520, you'll see that it gives us a warning message that there's too much crossover between the last excitation wavelength and the 520 emission wavelength. So if we think our fluorophore is going to emit around 520, we can enter in that value. We can give it any wavelength we want here. So if we can change it from 15 to 30, and you can see again that it gives warnings. So this is in order to better give you sensitivity for the spectral change and the Stokes shift. So here we're going to enter in the two different values. Let's say we wanted to read from 380 to 480. Then you can see the range there. We can choose the spectral resolution of 1 nanometer or less. And then this is where we choose between the excitation and emission scans. So when this is set up, we hit OK, and we can scan that plate now. We can start the measurement of the plate, and it's going to give us the spectral curve for that range that we chose in the excitation setting. When we want to go in and do the emission side, we just simply change the emission side, and you can see it's flip-flopped here. So now we have an emission range, and once we've known what the best excitation range is, we can put that value in. Let's pretend it was 450. We can set the bandwidth to be whatever we need it to be, and then choose the range for the emission that we'd like to try and scan. So both of the excitation and emission ranges are going to be perfect, and that's the best way to go about setting up the spectral scans for both emission and excitation, and then being able to get the optimal data for that.